Uh, so I'm going to share my screen so I have a little bit of slides for you. Okay, can everyone see this?
Yes.
Okay, great. So good morning, everyone. My name is Andre, and I'm a physicist at Caltech, which is a university up in Pasadena. So can anyone guess? Does anyone know what a physicist is? Any guesses? It's not someone who's really physical. So it turns out that a physicist is actually a type of scientist. So physicists are scientists who study two things called matter and energy. So matter is all the stuff that makes up the universe. So like I have a phone here, it's made of matter. I have some fruit that's matter too, and you and I are matter, and all the air in the universe that we're breathing. And energy is all the stuff that moves around and makes the matter move around and behave the way it does. So things that exist are matter, and energy makes them behave the way they do. So physicists are in the business of studying everything in the universe and why they are the way they are. So as an example, a lot of physicists study the solar system. And now the sun and all the planets, those are all types of matter. And planets orbit the sun, and that happens because of gravity, which is a type of energy. So physicists can study all sorts of things because everything is made of matter. So in this first picture here, that's a ruby crystal, which are a type of rock that people can dig up. And physicists who are studying this actually found that it can be used to make lasers. So if you're ever watching a science movie or a sci-fi movie and you see people shooting laser guns, you can think about the physicists like me who made that possible by studying this type of crystal. There are physicists who study really big things too, out in space. This is a galaxy in the middle. And there are physicists who study the really small things like atoms that make up everything else in the universe. So these are all really different fields, but in all of them, physicists like to make observations of something and use those to discover why that thing acts the way it does. So my job, I study something called plasma. So does anyone know what a plasma is?
It's like kind of like a type of beam in a way, I think.
A type of beam?
Yeah.
So not necessarily. So plasma is what we call the fourth state of matter. So maybe some of you know there are these three states of matter: solid, liquid, and gas. So if you start with a solid or something, maybe like ice, and you add a bunch of energy to it, it becomes a liquid, maybe like water. Does everyone know this? Is everyone familiar with these terms? So if you add some energy to a liquid, if you put water in the stove and boil it, it turns into a gas. And if you add way more energy, heat it up a lot, you'll start getting this thing called plasma. So plasmas are really, really hot, and they're a little bit like a gas, but there's two really weird things about them. The first weird thing is that they glow really bright. So that happens because they're so hot. And you can see this photo here on the bottom corner. This is a big lump of plasma, and you can see that it's glowing a really bright light that's all very blue. So gases don't really do that, right? But plasma is special, it glows like that. The other really weird thing about how it does that, how it interacts with those magnets and electricity. So if you're in a room full of air and you hold a big magnet, the gas won't really do anything. But if you're in a room full of plasma, maybe the plasma would go towards the magnet and surround you. So now I have a little demonstration here. I'm not sure if can people see my still. It looks like it's frozen to me. Can people see my video screen still? My camera? It looks like my internet is really slow. Okay. So I'm not sure if you can see on my screen that I have a little machine here. If you can see my camera. And this machine creates a plasma. So there is some gas inside of here. When I turn it on, it sends a bunch of electricity through it and uses a lot of energy. And that creates plasma. So it turns out that plasmas are all around us. And one of the biggest examples is the sun. The sun is a big ball of plasma. And it's really, really hot. It glows really brightly because it is a plasma.
Hi, Andre. I'm not sure, but is it? Can everybody hear? I'm not sure.
It's glitching
It's
for
kind of
me.
like cutting you.
Glitchy.
Yeah, it's glitchy. I can't really clear. I could hear him. It's just that his voice is glitching.
Should I try leaving and coming back?
Yeah, if you leave and come back, maybe that'll solve it.
Okay, I'll try that.
Okay.
So Mr. Andre has some really interesting things to show you guys. Did you see what happened when he touched the light bulb to the sphere? Yeah?
No,
Okay, so
the
electricity energy that's created.
From the inside, it was trying to get to the finger.
I did it.
That's right. He was trying to get to the light bulb.
I couldn't see it.
The camera was off on mine.
Okay. All right. So my suggestion is that you pin Mr. Andre's screen to your screen so you can see him big and we can hear him better, hopefully.
Okay.
I tried that one time and then I just got a really, really bad, like, sensitive connection, and then it just said, leave space or wait.
Okay.
After I tried to ping
There's a lot of strain going on the Wi-Fi. That's where you are, where Ms. Pua is, where Ms. Marquez is. So everybody's Wi-Fi is struggling right now. So that just means that we're going to have to be patient with it.
All right.
Patient. Thank you for being so patient.
Hi, everyone. Can you hear me any better?
Yes.
Can. Okay. I'll try this and see. anything's a little bit better. I think my internet's really slow. Okay, so can everyone see this again? Looks like it's still loading. In the meantime, if you can see my camera, I have this machine here that has a plasma inside of it. And remember how I said that plasma can have electricity and magnetism coming out of them? So I have a light bulb here. This isn't plugged into anything, but as I move it closer to this plasma, it starts to turn on. Can anyone see that? Maybe it's hard to see on my camera.
Wow, that's awesome.
Yeah, so this is not plugged into anything, but it's getting electricity from this machine that has this little plasma inside of it. So it turns out that plasmas are actually all around us. So one big example is the sun. So the sun is actually made out of plasma. It is made mainly out of hydrogen, which would be a gas on Earth, but because the sun is so hot, it's a plasma. In this middle picture here, does anyone know what this is? This is a photo from Alaska. And up in the sky, there's all these glowing lines. So these are called the aurora borealis, or the northern lights. And what happens here is stars explode millions and millions of miles away in space, and they send all these little particles that have a lot of energy. And those hit the Earth's atmosphere and cause part of the air to turn into a plasma. So you're seeing a little bit of plasma floating up in the air when you see the northern lights. Another example here on Earth is lightning. So when there's a really big thunderstorm, it causes a lot of energy to be stored in the clouds. And the air can't really carry electricity, but a plasma can. So all of that energy from the clouds, it goes into the air and causes air to form these little bolts of plasma that carries electricity to the ground. So that's why you don't want to be struck by lightning, because if you were, it's really hot plasma and it's carrying all this electricity from the sky. So in the bottom left corner here, this is called a nebula. And this is just like a big cloud plasma that floats up in space. And these things are huge. Maybe you can see every little point of light there. Those are all stars as big as the sun. And this big cloud holds probably thousands of stars. So those are all examples of plasmas in the universe. And those are the types of things that I want to study. But there are also plasmas we use in our technologies here on Earth that we can actually use because physicists are studying this stuff. So this type of light bulb here is called a fluorescent bulb. And for those of you in the classroom, this is probably the same type of light bulb that's up in your ceiling lights. And this actually has a plasma inside of it. These tubes are filled with a gas, and when you plug them in, it turns all that gas into a plasma. The same thing's happening with neon signs, like if you see an open sign on a restaurant. And all the different colors are because there's different types of plasma inside of it. And finally, here's a picture of fireworks. Fireworks are really bright, really hot. Well, turns out it's a plasma too. So my job is to study some of these plasmas. So I'm interested in looking at these plasmas in space and trying to figure out how they work. But they're really hard to study, right? If I go to the sun or maybe a nebula way out in space, it takes a really long time to get there, probably wouldn't survive the journey if it's too far away. And it's really hot. And once you get there, you can't really touch it or like stick anything into it to measure it because it would just burn up. But luckily, I can recreate some of that plasma in my lab here at Caltech. And that's a lot easier to work with. It's too small to hurt anyone. And it's just up the freeway at Caltech. And I can repeat the experiment as much as I want. So I can create the plasma over and over and keep observing things so that I can learn as much as possible. So in my job, I try to recreate the plasmas that are up in space inside my machines inside of my lab. Does that make sense? Cool. So that's the idea behind my work. So what do I actually do on an average day? So you can't really buy plasma. You can't go down to the stores, buy a big tub of plasma, right? Because it's so hot and it's really hard to hold because it's so high temperature. So I actually have to make the plasma myself. So the first thing I do is to build machines that can create the plasma and hold them. So I start out with equipment like saws and drills and cut pieces of metal into the right shapes and start to bolt them together to make these big machines. And then this big picture here in the middle, this is one of the machines I most recently built. So what this does is it has a chamber inside of it. And I pull out all the air because space doesn't have any air. I want to recreate those conditions. So in order to get rid of all the air, it has to be a really sturdy chamber. And that's what I build it to do. And then I have to create a plasma inside of it. So what we do is we have these big tanks of gas. We inject a little bit of gas in there, and then we zap it with tons of electricity. And it adds all that energy to the plasma, and it starts glowing. So you can see in the bottom right corner, that's the plasma in this machine. It's glowing a really bright purple. So my job here is to build the machine and also to build all the electronics that I use to zap the gas to turn it into a plasma. If you can see my camera, I have one of these little circuit boards here, and I built this. And what it does is it takes in low voltage, like from a battery, and it makes it really, really energetic and puts out a lot of electricity. So out of the other end, that's connected to inside of this chamber, and that's what zaps the plasma to give it all its energy and to make it into a plasma. So that's a lot of my job, is building the right conditions to mimic the plasmas from space here down on Earth. So the next thing I want to do is to be a scientist. So I have to make observations about this plasma that I created. So it's too hot to just go touch it, and it's also really bright. Maybe you don't want to look at it for very long, just like you don't want to look at the sun for very long, or at all. So we have a bunch of different ways to make observations in ways that are safe and that we can save the data and figure out what's happening later. So we can have this big camera that you see on the left side. This is a really fancy video camera. And all this does is you take a video of the plasma as it moves around in time. And these things can happen really, really fast. Like in a millionth of a second, a lot can change in the plasma. This camera is actually able to capture things that happen that quickly. Some other things that I like to do is maybe take the temperature of the plasma or the pressure, trying to figure out how much plasma is actually there. So I have another little device here that looks like a little light bulb. Maybe you can see it in my camera. And what this thing does is a plasma gets into this little light bulb thing. And when it's on, this thing is glowing. And this can actually tell how much plasma is in there just by how much it hits the little filament that's glowing inside the light bulb. So another thing we like to do is shine lasers at the plasma. So if you can see this photo on the left side, or on the right side, sorry, this big machine here, that's actually a really, really big laser. you wouldn't want this to hit you. Have to wear special goggles and special clothes so that it doesn't injure anyone. But what we do is we shine this through the plasma. It turns out by watching the way the laser beam is deflected through the plasma, so how much it gets dimmer and how much it moves inside of there, we can figure out a lot about what the plasma is and what's inside of it. So when you observe things, it's not just looking at it. It's doing all these different things, taking data about what I'm looking at. So I'll use these machines to create a plasma, and then I'll observe it with all of this stuff. And then after I'm done with all of that, it's time to figure out what I was looking at. So now I have to put together all of my observations and try to make a theory of what was actually happening. So a really common way to do this is with computers. So you can see on the right side here, these are all pictures that I took of the plasma at all different time steps. So this is 1 millionth of a second. So this is 4 millionths of a second after I started this, and it goes all the way to 11 millionths of a second. So this happened really, really fast. But you can see how much the plasma changed in that time. So then I can use computers to make graphs like this. And this one shows how much light was coming out of it, but I can also look at how the temperature changed in time or how the energy changed in time. And from all of these different things, I can start to understand what actually happened in the plasma more than I would just by looking at it. Another really common way to figure some things out is to use math to describe it. So physicists have a whole bunch of equations that we use to describe the universe. And if we can make those equations match what we see in the experiment, we can even learn new things about the experiment. We can try to figure out better what's going on if all the math works out. So I do a ton of math too, to try to figure out how what I'm seeing matches our theories of how the world should work. Okay, so that's a little taste of what I do in my daily life. I'm just building experiments, I'm observing the plasma inside, and I'm analyzing that data to try to learn how the plasma works. And from there, I can figure out how those plasmas in space work, like the sun or the galaxies far away. So what did it take me to get here? So the first thing is there's a lot of education involved. So I had to go to high school, I had to go to college for 4 years. And then I have to do this thing called grad school, which if you want to be a really good physicist, you have to learn a lot more after college. So I'm currently in this thing called a PhD program, which is a way that we can become an expert in our field. And it's a mix of learning things from books and actually having on-the-job training working with other physicists. So there's a lot of education involved here, but it's not all like school that you're in now. You get to really focus in on things that are interesting. So the last thing that I think you need is a passion to understand the world, to look at the world and want to know how it works, or at least some little part of it. And that's what drives physicists to keep learning. Okay, so that's just about everything I have for you today. Are there any questions about my job or anything I talked about?
What got you into doing it?
Well, that's a good question. So ever since I was interested in science in general, I was a big dinosaur kid and a big space kid. So being a scientist was always something on my mind. And as I got older and started going to college, I found this field about plasmas, and I thought they were really weird because it's not something you really interact with on Earth. And it ties into stuff in space that I thought was so cool. And eventually I just got involved in this specific field. So it was sort of just being interested in different things and following it until I sort of fell into this job, and I really like it.
What's your favorite thing of doing in your job?
That's a good question. So probably my favorite thing is actually building everything and watching it come together. So I start off with basically nothing and just have a bunch of materials. And then from that, I make it into these big experiments. And it's really fun to see, after a lot of work, to see me finally create a plasma inside of it. And it grows this really pretty color. Usually it's really purple or really blue. And it's just a lot of fun to see it happen and to see all these weird things happening inside of the machine that I built from scratch. Okay, any more questions?
Adrian said, how much do you get paid?
Yes. So how much I get paid, that sort of changes as how long I'm a scientist. Right now, I'm still in a training program, so I don't get paid. But scientists who are experts, once they finish all the schooling, they can get paid a lot more, maybe similar to teachers or other jobs like that.
What's the longest experiment that you've had to run?
Ooh, so the longest one that I've run took probably about a week of just constantly looking at the plasma and trying to figure out things that happen. But we usually run all of these things over and over, trying to take more observations, and that can last years and years. So I'm working on an experiment right now that was actually built 18 years ago. And people have been working on this. I was younger than you are now when it was first started. But it's kept going on for decades now. So there's always more to learn about things like these plasmas, and yeah, if you keep exploring it, they can go on for a really, really long time.
How did you choose plasma to study?
Ooh, good question. So it was just something that I sort of fell into after having a lot more interests that I was looking at in physics. So I had been interested in really high energy stuff, like the particles that make up matter. And I was also interested in how fluids work. It turns out that fluids like water or corn syrup, they act in really weird ways. And I was doing a lot of research about that. And then I found out that plasmas use the same sort of methods, except they do a lot of weirder stuff. And I thought that was really interesting. So I just sort of fell into the topic and really liked it. Also, I like
Any other questions, guys? Any other questions, guys? Okay. All right. How long does it take to build a machine like that?
Ooh, good question. So it can take a really long time. I know one experiment that I've been building has taken almost 2 years. That's mainly because the pandemic really slowed us down. It's supposed to take about a year. But it's a really long process because there's so many little complicated things that go into it, including building all the electronics, and the one I'm building right now, it has to get really, really cold. So we have to get all these really fancy pumps that get down to minus 300 degrees. So in order to do all of these things, then it just takes a really long time to set up.
What was the first thing you built?
Ooh, so the first thing I built, I think it was a little piece of equipment that we used on a much bigger experiment. And what the thing did was it looked at light from the plasma, and it broke it down into a bunch of different wavelengths, which is a bunch of different colors of light, basically. And from that, we can actually tell what kind of things are inside the plasma, so they all glow a little bit differently. So my first experiment was to set that up, to separate all the different colors of light and look at how much of each there was in there.
Wow, that sounds really interesting. Well, thank you very much, Mr. Nicolov, for Mr. Andre, for coming and joining our class and talking to us about it. I believe your next group is going to be waiting for you at this time, but we're very happy that you can accommodate us and teach us about what you do.
Thank you for having me, and thanks for listening, everyone.
Thank you. It's super awesome.